Good morning, friends. In this video, we will see about fixed bias. This is one of the biasing circuit for BJT. So we can see that a transistor NPN transistor is shown here. It's a CE circuit with single base resistor. You can see there is only one RB resistor connected to the base. Hence the name is called single base bias resistor or fixed bias resistor. First thing is we have to find the Q point of the circuit. For that, we have to first find the DC equivalent circuit. Here we can see this is the input voltage. There is a coupling capacitor CC. So the coupling capacitor act as a open circuit to DC. So what we have to do? We can remove this coupling capacitor. So your circuit will after that the capacitor act as a open. So the circuit will looks like here. The remaining part of the circuit is here. Okay, so the DC equivalent circuit looks like something here. What does it happen is the entire circuit got isolated from this input voltage. So here is this is the DC equivalent circuit. Just this part get open. Okay, the circuit got separated from this input voltage. So how this is how we can get the DC equivalent circuit. Now we have to find the Q point of the circuit. Here is the output characteristic curve. We know that this is VCE and this is IC. It will be in milliamps. The first thing we have to find the endpoints of this load line. This point and then this point. For this we have to write the KVL at the outer loop. What is the outer loop? This is the outer loop. So BCC, this is BCC. The positive terminal of VCC is connected to a resistor which is RC. The current flowing through is IC. This Q represents the Q point. So we started with BCC and then this RC, and after comes, you can see there is a VCEQ here. We can write it as, after that there is a drop of VCE, then the last is grounded. So this is the outer loop of this transistor. So VCC, ICRC, and again this VCE, and the next part is this part is grounded. So if you write a KVL here, it likes minus VCC plus ICRC plus VCE equal to 0. Okay, now we have to find the end point. To find this point, that is a point on the x-axis, we have to make this y-axis to be 0. The first thing is, so set IC equal to 0. If you make IC equal to 0 in this equation, which comes VCC equal to VCE. So this end point is VCC. VCE equal to VCC. Now second point is set. To find the point on the y-axis, you have to make this x-axis to be 0, which makes set VCE equal to 0. So if VCE equal to 0, what happened to IC equal to VCC by RC. So this point is VCC by RC. So now we got what are the endpoints of the load line. The next thing is to get the Q point. To get the Q point, the first thing is we have to write KCL at the input side. Okay, so at the input, here is a loop. What is this? So VCC is connected to, which is RB. At the end of RB, here is a potential drop of VBE, and then that part is connected to ground. So this is the input loop equation. If you write a KVL here, minus VCC plus IBRB plus VBE that is equal to 0. So at Q point, what is that? IBQ. Just this Q represent the Q point. What is the base current at the Q point? Which is VCC minus VBE divided by RB. So we got what is IBEQ. We know that IBEQ, beta IBEQ equal to ICQ. If you know beta from this equation, we can find out what is ICQ. Okay, now we got what is ICEQ. Next thing is to find what is VCEQ. For that, you have to write KVL at the output. So this output already we have written this equation. So minus VCC plus ICRC plus BCE equal to 0. From this we have to find what is BCEQ. So BCEQ equal to BCC minus ICEQ RC. We already know what is ICEQ. ICEQ we can substitute here to find VCEQ. So now we have got the Q point, VCEQ, comma ICEQ. That we can plot it here. This is the Q point. So this point is VCEQ and this point is ICEQ. So in next video we will solve numerical on this, and we will discuss what is the disadvantage of this fixed bias. Thank you.